Welcome to the city of Hamina in Finland. Now I've got here a Google Maps satellite image of the city of Hamina, which I've imported into Hamina Network Planner. And I've used this map to create a 3D model of the city. You can see all the buildings modelled here. And I've done this because I want to design cellular coverage for the city of Hamina. So how am I going to do that? Well, I'm going to do that by coming down here on the toolbar to access points. And you will see that I've already selected the 4G, 5G technology. This is the access point I'm going to use. And I've got it configured for a height of 15 meters. And I'm going to place this access point on the center of this central building with an omnidirectional antenna with the hope of covering the whole city of Hamina. So here we go, that's it on that building, and we can now see the heat map of the cellular coverage. So how have we got on? Is that good placement? Well, let's take a look. If we take a look here at the legend for the heat map, we can see that anything above -80 in the cellular world we're considering excellent, and anything -90 dB or better is considered good. So the good signal areas are indicated by this yellow-orange contours, and the excellent areas are going to be green, as we have here. So as we assess our coverage, have we done a good job of covering the city of Hamina? Well, in some areas, yes, we've got good coverage, but in other areas, we don't have very good coverage. And you can see when we look at this in 3D, it tends to be the areas behind the buildings where we're not getting very good coverage. Why is that? Well, that's because Hamina is predicting and modelling its coverage using free space path loss algorithms. And what they do is they model the signal dropping off as it leaves the antenna, and when it hits an object which attenuates the signal like a building, it applies that attenuation to the signal. So the other side of the building, we have a lot less signal, and you can see behind a lot of these buildings we just have no signal at all. The problem with that is that's not really how our app works. We know that if we have a cellular mast up in a built-up area like this, that when we walk behind a building, we don't completely lose signal. And that's because we know that the RF signals are going to reflect and diffract around these buildings. So is there anything we can do about it? Well, that's where the magic button in Hamina comes into play. What is the magic button? Well, the magic button, or what I call the magic button, Hamina actually called the compute FRT heat map. I prefer the name magic button. But what does it do when we press it? Well, when we press it, it starts to perform some fast ray tracing calculations. And what these calculations are doing is they're going to start to calculate the reflections and diffractions of this signal around all these buildings. And it's going to produce for us an accurate heat map taking into account all the reflections and diffractions. And now it's done that, we can actually see we've got great coverage around the city of Hamina. Look at that. Isn't that magic? If you've enjoyed this video and want to become a Hamina expert, why not book yourself on the Hamina Certified Network Architect class? You can see the current course schedule at mqts.co.uk/Hamina-training. Thank you for watching. Goodbye.